Let's take a look at what input means in PLC ladder logic programming. The way we write input is as following, as two bars facing each other representing the input. And to differentiate between the physical input device and the input within the software, we refer to the input in the PLC program as input instruction. There are two main types of input instructions: examine if close, XIC, and sometimes called normally open; examine if open, XIO, and sometimes it's called normally closed. Notice that the only difference between them is that the XIO has a sidebar that indicates it's already closed and we're examining if it opens. In ladder logic program, the instruction is highlighted when the logic state is true. I'll be using a green highlight in the slides here, similar to what is used in Allen Bradley software. However, it's very similar in any other PLC types. Different colors might be used in different softwares, but they all indicate the same concept. Examine if close, examine if open instructions tell the processor to test for an on condition from the reference address bit. Simply, the instruction checks a memory location, and according to the bit, 0 or 1, then the instruction is either activated or not. So here's a simple layout of a digital input device connected to a PLC input module to provide an input, and it has a specific memory location to indicate the status. And by using this memory location address in the PLC instruction, we can connect the physical to the program we are writing. So, the input signal is received from a physical device. The physical device is connected to the PLC input module terminal, and the bit is then stored in an input memory address location. And according to the bit address, the input instruction behaves accordingly. The two input instructions, XIC, examine if close, and XIO, examine if open, are Boolean type, which means either on or off, 0 and 1, and we refer to it as the logic state. In the case of examine if close, XIC, the instruction is highlighted when the memory location associated with it is 1. Usually in many softwares, a green highlight is a representation that the logic state is true. So, XIC is true when the memory address bit is 1 and is false when the memory address bit is 0. The XIO, examine if open instruction, acts the opposite way. It is activated when the logic state is 0 and not activated when the logic state is 1. So, XIO is true when it has a 0 and false when the logic state is 1. To summarize, in a ladder logic program, the instruction is highlighted in green when its logic state is true. Example, 1 is not necessarily true as we saw. True, active, or highlighted all mean the same thing, simply means an on condition. The difference between XIC and XIO is when each of them is true. XIC is true when the logic state is 1. XIO is true when the logic state is 0. So try not to associate 1 as true. Inputs are written in the left side of the ladder logic.